Welcome to Study Loop.
Hi there. In this problem, we have a reaction to magnesium, which is solid, reacts with oxygen gas to make the solid magnesium oxide. And it makes 2 MgOs. And we're also told the enthalpy for this reaction is negative 1,204 kilojoules. All right, so let's check out the questions here. The first question asks if this is endothermic or exothermic. Well, we see the negative sign there, and by convention, when we see a negative sign, it tells us that energy is being given off. In other words, it is exothermic. All right, so this reaction is exothermic, energy being given off, the negative sign, and the heat is telling us that. All right, and then we have some stoichiometry problems to do. Letter B wants us to calculate how much heat is transferred if we start with 3.55 grams of magnesium. So, like I said, this is pretty much a stoichiometry problem. We are going to have to convert from grams of magnesium to moles of magnesium. So looking at the periodic table, 24.31 grams of Mg in every mole of magnesium. And then, again, treating this like a stoichiometry problem, where the enthalpy change is the enthalpy change that we get for 2 moles of magnesium, because the balanced equation is showing us that. If we start with 2 moles of magnesium, we get the enthalpy change of negative 1,204 kilojoules. So this will tell us the enthalpy change if we start with 3.55 grams magnesium. Notice the grams cancel, moles of magnesium cancel, and we are left with the enthalpy change. Calculating this, we get negative 87.9 kilojoules, which is our answer for part B. Part C is basically going to be the same thing, only in reverse, because now we are starting with the enthalpy change. And we want to know how many grams of MgO are produced when we see this enthalpy change. So the enthalpy change is negative 234 kilojoules. Looking at the information we're given in this problem, we know that an enthalpy change of negative 1,204 kilojoules is what we will get when 2 moles of MgO are produced. All right, and we want to know grams of MgO. So next step is going to be converting from moles of MgO to grams of MgO by using the molar mass. Molar mass for MgO is 40.31 grams of MgO for every mole. All of our units will cancel now except for grams of MgO, and we will get 15.7 grams of MgO, which is our answer for part C. Part D wants to know if we want to reverse this reaction. We're trying to decompose the MgO, specifically 40.3 grams of the MgO. If we want to decompose that, we want to know how much energy, how many kilojoules of heat have to be absorbed. So still essentially the same type of problem. I'm going to convert to moles of MgO. There are 40.3 grams of MgO in every mole of MgO. And then we see that for every 2 moles of MgO that we want to decompose, if we are reversing this reaction, then the sign on the enthalpy change is going to be positive. It's going to take 1,204 kilojoules of energy to decompose 2 moles. Calculating the answer here, we will get 602 kilojoules. And again, the sign on that is positive because that is energy that is going in. It would be endothermic if we are reversing this reaction and decomposing the MgO. All right, and that concludes this problem. Thank you so much for watching.